Hello, this is mathjazz from Almost Cool. This video is a tutorial video on Mathematica, which is a fantastic program. I'm primarily making this video because students at the university where I teach are given free student copies of this program. If you are a student at the university where I teach, you can go to the Office of Information Technology, so OIT, and you can ask them to put a free copy of Mathematica on your computer. I think it'll be version 10. I have version 8 on this computer, and I should probably update that. But for much of the the mechanics of it, demonstrating on Mathematica 8 will be sufficient. Anyway, this is the program. This is Mathematica 8, and I'm going to show you some of the things that a notebook can do. So here is a notebook. Now, I usually find it helpful to open the documentation center and just keep it to the side here for help. The documentation center on Mathematica is wonderfully done. I can type in lots of different commands, maybe like plot, for example, and it pulls up the syntax of the command, and it gives several examples of how to use it, and you can find more information about the particular command that you're looking for. If you don't know the name of a command, maybe I want to do something, but I'm not sure what the name of the command is. So maybe I type in like graph function, for example. Now I can plot a graph, and it'll tell me about the plot function, which is exactly what we were looking at before. Well, this page is different, but this is the function you'd use, and you can now click here, and this is the page we were looking at before. This is kind of an overview on how to graph or plot, and these are other things related to the search phrase graph function. Well, anyway, here is a notepad, or a notebook. And so in here, we have things called cells. And by typing, you'll automatically create one. So here is a cell. It's this line of code here, which just has this variable a. And if I click beneath the cell, I can create new cells. I can select cells on the side and delete them. Everything works fine. Cells are going to be the primary way that we do things in Mathematica. So, for example, if I want to use this just like a calculator, I can do that. I can have 12 plus 34. Now, to execute a line of code, you're either going to have to hit Shift and Enter, or conversely, I can hit the Enter in the number pad of my keyboard. That will also execute the code. I can put a different arithmetic problem on each line by hitting Enter. Hitting Enter gives me a new line to put code on in a cell. That's why hitting Enter doesn't execute code, but hitting Shift Enter does. And notice this cell has 3 lines of code, and I have 3 output cells here, and they're in order of the problems that I placed. So I can use this just as a calculator, and it's a nice calculator at that. Now, if I want, see this this answer here came out as a fraction. If I want to get this as a decimal, I can use the first command that we're going to discuss today, the n command. Now, all commands in Mathematica, all native commands, the ones that come with the program, are going to have capital letters. They use a modified camel case. That is, every word in the command. Some commands, or some functions, are multiple words long. every word in the name of the command will be capitalized. The N command, of course, just has the letter N, and it's capitalized. All commands have square brackets for their argument, and the N command will take a number that it is given and will give back the decimal value for it, or a decimal approximation. So 34 sixths is about 5.6667. It's probably 6 repeating. In fact, I'm sure it is 6 repeating, but it rounds after these decimal points here. And I could use the N command on everything else, and it'll give me, 46, and then it'll put a decimal point to say that it is precise at least to the 46. Okay, so this is how we can use the notebook to do calculations doing arithmetic, but we can also define variables. So I'm going to do that down here. Let's say that I am doing something and I want to define a variable a and give it some value, like 3. I can do that. I can actually define several variables in the same cell. So I can define a, b, and c like so. Now, whenever I use the letters a, b, and c, it'll bring up the values that are stored in here. So 3 plus 4 plus 5 is 12. A over b is 3/4, or I can use that number, sorry, the numerical command, that is the N command, to go a over b and get 0.75. Now, it actually doesn't matter if I delete all of these cells. Mathematica will remember that a is in fact 3, b is 4, and c is 5, because on an earlier step of evaluation, it stored those values to those variables. So I can hide those there. Now, I can also define functions. And the way that I do that is I give my function a name. I can give it f, which is my favorite name for a function, or I can name it whatever I want. Function. Notice the text is blue because anything that Mathematica does not recognize as having a value will be blue. Notice that, for example, a is black because it's been defined, but d is blue because it hasn't. So I can define a function like so. I put square brackets for the place, sorry, this is the argument of my function. I can name the variables that are in it using underscores, so I can have a function that takes an x and a y, for example, and I can say like x squared plus y. This is a function, and I need, this is a colon equal sign is what I need there. That expression tells Mathematica that this is a function if I have variables with underscores and a colon equal sign between the name of the function and the definition of the function. So this is a function that takes in 2 variables. It squares the first one and then adds the second one to it. It's a perfectly valid function. I can also have functions that just take in 1 variable, and that is also okay. So f of x equals, there's my colon equals because I'm defining a function now. I can do x squared plus x. And when I hit Shift Enter, it'll define those functions, and they are now stored for me. So I can take f of a, and that will equal 12, because I have 3 squared is 9, plus 3 more is 12. Or I can take function of b and c, and that'll give me 21. That's 4 squared is 16, plus 5 is 21. So, one thing that's also interesting about functions is, well, it's a useful feature in Mathematica to use lists. I can define a list, say I want to name it D, and I use the curly braces here to define my list. I can define a list A, B, C, and now instead of storing a number in a variable, I am storing a list of numbers in my variable D. If I hit Shift Enter, it does that. So D will pull up a list of numbers. If I do f of d, what's going to happen is it's going to apply f to the first value and store that in a list, and then apply f to the second value and store that in the second spot in the list, and then do f to the third value and store that in the third spot to the list. So, like so. Now, some computer scientists will be sad that I said the 3 is stored in the first slot. So f of 3 is stored in the first slot because a lot of CS majors are told that lists start at 0. Mathematica does not do that. Mathematica starts at 1 for its lists, and it took a while for me to come to terms with that. But Mathematica does not have a 0th position at the beginning of a list. It has a first position. So if I want to call up elements of a list, here is the list D. If I use 2 square brackets and a number and close with 2 square brackets, this will now pull up the second element in the list. So this is the 4 in the list. Or I can do f of d again and pull up the third element in the list if I want to. So what I just did in line 28 is I applied f to d, so f of 3, comma f of 4, comma f of 5, and then I pulled the third element out of that list, so f of 5, which was 30. So now that we have a little bit of a knowledge of lists and defining functions and defining variables, we're going to learn another function of Mathematica, which is going to be the solve function. So solve is spelled S-O-L-V-E, solve, and it takes in an argument of an expression. So, like, for example, f of x equals 5. So this is going to take the f function we had from before, and it's going to, I need to have 2 equal signs here. One equal sign is an assignment. That's a definition in Mathematica and in a lot of computer science language, a lot of computer programming languages. One equal sign will mean the thing on the left is defined to equal the thing on the right. Or you can think of it as I'm storing the value on the right into the memory slot named by the thing on the left. When I'm using 2 equal signs, that's an actual equal sign in a mathematical sense. I am checking to see where f of x equals 5 when I write this solve f of x equals 5. And now I hit Shift Enter, and it gives me this. And this might look confusing, but this is a list. It has a curly brace to open the list, and then it has another curly brace and a closed curly brace. This is called a replacement rule. It's saying that x, which is my variable, equals this value. This is one solution of the equation. And that makes sense. We have a parabola, so we might have multiple solutions. In this case, we had 2. And over here is the second solution of our equation. So we have a list given by the first and last bracket, and then we have what's called a replacement rule, and those are just saying that you can use replacement rules on expressions or on functions to plug in particular values, and we'll see how to do this later. But we have a replacement rule which is saying that x equals this value, and we have another replacement rule that's saying x equals this other value. So if I were just wanting to solve a function, I could actually just like read these values out here. But let's say that I wanted to solve this function for this value, and then I wanted to plug these values back into our function for some reason, or into another function maybe. Maybe we'll define another function, g of x equals 2x squared. We'll define a new function. Let's say that I wanted to find the solutions for f and then plug them into g. I can do that. I can do solve f of x equals 5. And this will give me a list, this list with these replacement values. I can say g of x, and then I'm going to use a command called the replace command, which is /dot, like so. And then what this says is that you will solve this function for this value, and then you will use your replacement values in this expression here, which is g of x. And so when I hit Shift Enter, I get this. And this is a list of two values, and each of these values, this value is g of x equals that, and this value in the list is g of this value here. So this /dot says use this list of replacement values on this expression, replacing x with this value. So if I had said, like, solve f of y equals 5, I'm going to get a replacement value where it says y equals this, and then my function here isn't going to know where to plug y into g of x because this is the wrong variable. So if I did this, I should get nonsense. Yeah, see, it gives me back g of x, but it doesn't know how to plug in the variable because this variable here is different from the replacement values that solve got because solve's variable was y. Okay, so that is a way of solving a function and plugging in the answers you got from that function into another function. And now we're going to work on the plot command. Now, the plot command is really nice. It draws very nice graphs. You have to plug in a function, and you can plug in a function you've defined like f of x and give it some range like x goes from -10 to 10, and then we close our bracket. I already closed my plot. Now this says plot the function f on the range x goes from -10 to 10, and it'll give me my graph like this, which is beautiful. It is a beautiful graph. I can graph multiple functions on the same graph, and I don't actually have to define the function earlier. I can use pre-built functions like sine, or I can just make my own function like x squared. We already have an x squared with a positive coefficient. Let's make an x squared with a negative coefficient, minus x. So notice that I'm using a list here. There's a curly brace, everything is separated with commas, and then it closes. So this is saying plot this object, but this object is a list of functions. So the plot command is going to graph each of those functions one at a time, starting with the first, and it's going to graph them on this this domain, which is also a list. If you're being very shrewd, this is a list. Plot is told to take an object, which is a function, and a list, and then the first element in the list is the variable, and the second two are the endpoints of the plot. Now, if I hit Shift Enter here, I get the plot of f in blue, and then I get the plot of sine of x, very, very small against the axis. Maybe we could zoom in a bit to see what's going on here. But we can kind of see it. Maybe if we cut this down to a smaller, yes, we can see here is our sine graph, this red graph right here. And then we see the yellow graph here, which is the graph of negative x squared minus x. So, yeah, so now we have the ability to plot actually several functions on the same graph if we choose. We also can plot in 3D. So this is a 3D plot, and we're going to use the function that we defined earlier, which was function of x and y. And we'll define that from x negative 10 to 10, and y also from negative 10 to 10. There we go. So with this plot function, we take in a function and then two lists. The first element in each of the lists is the variable, and the second and third are the endpoints of the graphing box. So we hit Shift Enter, and we get a beautiful graph. So since x was squared, we get something that looks parabolic from this side, and since y was a linear term, we get something that looks kind of like a line from the side. Notice that I have a small slope here. It's probably most obvious looking at the bottom of the graph here, how it's just slightly going up like a line. But it is a beautiful graph. There are nice ways of coloring these graphs too, using various plot 3D functions. But that might be saved for another video. You can look into some of the options, like controlling the texture and the color of the graph. So, the last thing we're going to talk about in this video is we're going to talk about formatting cells. And this is really nice if you want to do your homework, if you want to type your homework to send it in. So we're going to create a cell, and we're going to format this cell. Sorry, we're going to format the cell going under Cell, Convert to, and then Traditional Form. And then we'll go to Format, and we'll go down to Text Alignment, Align Right. And now I can type my name in this box. So, mathjazz is my name, and we can have, we're in Calculus 1, and we are in some section of it, so how about section 1? And this is the first homework assignment, the homework one. So I have my heading up here. I can start another cell. We'll convert it to traditional form. And I'm just going to write all of my problems in here. So like problem 1, we'll say, I'll put that in another line. A ball is launched into the air at a rate of 10 meters per second. On Earth, starting from an elevation of 0. How high is the highest point of the ball's trajectory? Okay, so from here, my solution can be that since acceleration due to gravity is negative 9.81 on Earth, and velocity is the antiderivative of acceleration. We know that A of t equals negative 9.81 meters per second, and velocity at time t is equal to negative 9.81 t. We know that the velocity initially was 0, so the constant term on velocity is 0. Since the position function is the antiderivative of the velocity, P of t equals negative 9.81 t squared over 2. Sorry, the initial velocity was not 0, it was 10, so we have to add 10 here, which gives us plus 10t here, and the initial height was 0. That's what I was thinking of. This height is 0, so the constant term on the position is 0. Okay. So now we have, you know, our written part of the assignment done. We know our acceleration, our velocity, and our position. So we'll just define these functions here. A of t, we have to put the underscore or else our function doesn't recognize that is a variable, colon equals negative 9.81. V of t equals negative 9.81 t plus 10, and P of t equals negative 9.81 t squared over 2, and we'll help it out with a set of parentheses. I think Mathematica does know not to put the over 2 in the exponent, but we'll just make sure. Plus 10t, and we forgot a colon here. Now, notice that A is black while V and P are blue. That's because we actually already defined A earlier. Now, it's not going to let me define this because Mathematica thinks that A is 2 now, because, or sorry, A is 3 now, because that's what we defined A to be earlier. So if I hit Shift Enter, it's going to throw an error. And it says set delayed write tag integer is protected. It's saying that 3 is not a variable, it's not a function. You can't make 3 into a function, and that's why it failed. But the way to get around that, the way to delete saved information is going to be you go to evaluation, and we're going to quit the kernel. This will delete all stored variables and all stored functions and all stored everything. I do that, I quit the kernel, and I will now delete these 2 cells here just because they're in the way. If I hit Shift Enter now, it defines the 3 functions. Now, I want to solve. I have to use a capital S because this is a native function, not one that I defined. I want to solve v of t to equal 0. Because when v of t is 0, then the derivative is 0, and that's where we get our maximum. Now, that's well and good, finding out where the point is maximized, but I also want to figure out how high that point is. So solving where v of t is 0 gives me the time at which t is 0. I'm going to hit t/dot just to make it not a replacement rule and make it a variable itself. Now, under here, I'm going to have P of t, and I am going to also use the slash dot command and go solve v of t equals 0. There are shorter ways to do this. I can use a repeat command and it'll just take the answer from the previous line, but I'm going to type the command anyway. Now, when I execute the command now, it's going to give these two numbers. The first of which is the time at which the ball hits its highest point, because we're looking for at t when the velocity is 0. The second one is p of t, where t is the time the ball hits its highest height. So this is the first number is the time at which the ball is highest. The second number is the height at which the ball is highest. And so I can actually from this I can convert this cell to a traditional form cell, and I can write out the time at which the ball hits its highest point is, and I'll delete the parentheses, seconds, and the height at that time is, and I'll convert this cell into traditional form 2, and I can combine these two cells using right-clicking and hitting merge cell. I'll delete that parenthesis and this one and the space and write meters. And then I can move on to my next problem if I choose. But we can see how this actually provides a very nice way of calculating your solutions to your problems, and also typing up your solutions to your problems, especially if LaTeX is kind of intimidating to learn. This is a nice alternative to LaTeX if you're wanting to type up math without having to learn something as technical as LaTeX might seem. Although LaTeX does produce, I think, prettier results. Very, very nice papers from people that have studied LaTeX and have developed that skill. We might do a video on LaTeX in the future, but that probably is uh, most calculus students are not taking several years of math, so LaTeX might be a skill that is not doesn't pay off as well as learning Mathematica does. Anyway, this is our video. I hope that you're having a great time learning calculus, and I hope you're having a great day. I hope that you found this video interesting and are able to use Mathematica or maybe MATLAB even to do your homework, to type up your homework so that it looks nice and clean. And again, have a great day. Goodbye.